Lesson 39, Algebra 1, the trichotomy axiom, negated inequalities, and advanced ratio problems. So I'm going to start with advanced ratio problems because those are usually what give people the most trouble. So starting in practice A, they tell us the team played 65 games. The ratio of wins to losses was 3-2. How many games did the team win? Alright, so we kind of have to use some information here to figure out our ratios. So they tell us the ratio of wins to losses was 3-2. And they want to know how many games the team won. But the information they give us is not number of games won or lost. They give us the total number of games played. So what we have to do here is we have to create our three ratios that exist in every single ratio problem. So here we have what's called part to part, the wins to the losses, and then the number of games played would be the whole, or the total. So now we have to find a way to write a ratio of wins to total and losses to total. But how do we find the total number? Well, that's easy. The part plus the part will equal the total. So if you have both the parts of the total, you can add them together to get the total number of 5. From there, we just take each individual number and put it over the total. The win number is 3 and the loss number is 2. Now that we've written our three ratios, we have to figure out which one we need to solve the problem. So we'll go back, read the problem, and find out what they're telling us. They want to find how many games the team won, and they tell us information about the total games played. So we need the ratio that uses wins and total. So if we look back at our three ratios, this is the one we're going to be using. So we'll do 3-5, and that's wins to total. And they tell us they played 65 games total. So for the total number, we put 65, and the wins will be our unknown. From here, we cross multiply. We get 5W equals 3 times 65. I'll divide by 5. And I see that 65 can be divided by 5. Now, if I remember on the multiplication tables, I know that 5 times 12 equals 65. So 5 times 12 equals 60. So 5 must go into 65 13 times. So 3 times 13 gives me 39. So our answer is 39 wins. Now let's go to problem B. The ratio of hard problems to easy problems, the ratio of hard problems to easy problems is 23-7. So I'll start by writing my first ratio. And that is hard to easy. And that's 23-7. Sounds a little bit like your homework, huh? Now they want to know how many easy problems were there if the total number of problems was 930. Okay, so again, they give us the total number, and we don't have any information about how many were hard or how many were easy. We have to find how many were easy. So we'll start by writing the three ratios. So we'll start by writing hard to total, and then we'll write easy to total. Again, the total number is going to be the parts added together, so the total number is going to be 30. The hard number is 23. The easy number is 7. And the problem says we got to find how many easy problems there were if we're given the total number. So we have to use the ratio of easy to total, and that is this bottom one down here. So we'll do 7 over 30. That's easy and total. And they tell us that the total number of problems was 930. So we'll put 930 down here with the total. And then easy will be our unknown. We cross multiply. We get 30 times E equals 7 times 930. So let's reduce. Well, from here I can cancel these zeros, and then I can divide pretty quick mentally and say that 3 goes into 93 31 times, because 3 goes into 9 3 times, 3 goes into 3 1 time. So 31. So 7 times 31 will give us our answer. So let's take 31 times 7. Get 7, 3, 2, 217 easy problems. And that's our answer. So that's advanced ratios. We just have to make sure that we write the three ratios that come with every problem and then choose the correct ratio to solve. Now let's go to the trichotomy axiom and inequalities. Starting with C, they tell us to draw a number line and graph the solution to x is not greater than and not equal to 2. So we'll start by writing that down. And what the trichotomy axiom says that there's only 3 possibilities between two numbers. Those 3 possibilities are equal, greater, or less than. So equal, greater than, or less than. And sometimes it helps to write these out. And what this is telling us is that it is not equal and it's not greater than. So the only option left is that x is actually less than 2. So our actual equation is x, or inequality is x is less than 2. And we're going to graph this number, not this one. So we'll draw our number line. We use 2 as our starting point. We can draw an open circle because it's not equal to, and then less than leads us to the left. So this is our answer. Now let's go to D. We have to write both an inequality and negative inequality that describes this graph. So what they're asking for is for us to write both of these statements in reference to this graph. So we'll start with the easy one. We'll start the inequality. So we see that the graph starts at -1. So we're going to have x and -1. And then we see the graph has a closed dot. So equal is going to be an option. And then the graph goes to the right. So that means greater than. So we're going to say x is equal to and greater than -1. Now if you remember the trichotomy axiom, there's only 3 options: equal, greater than, or less than. And we see that the graph is equal and it is greater than. So the last option is going to be not less than. So we can write x is not less than -1. And these are our 2 answers.